Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. In today's video, we are going to talk about gasket joint. The content is taken from the book Shigley Mechanical Engineering Design, and the pictures is taken from the book itself and randomly from Google Images. So, what is a gasket? Gasket is a mechanical seal which fills the space between two or more mating spaces, generally to prevent leakage from or into the joint objects while under compression. If you remember in one of the video, they are talk about gasket. The function of a gasket to distribute the force. Another function of a gasket to distribute the pressure evenly among the mating component. Okay, let's say you made this with a part. Okay, and then this bolt and that part, the pressure with gasket it will distribute evenly. Okay, but without gasket, that pressure uh, cannot distribute evenly. And another function of a gasket, if we putting gasket, we can calculate uh, the stiffness of the bolt and the stiffness of the member. If you do not put the gasket, it is difficult to calculate because the pressure uh, is not distribute evenly among the mating components. This is another function of a gasket, but people usually using gasket to prevent leakage to from or into the joints object while under compression. Okay, you can find gasket in engines, in usually in engine parts where oil components are involved. Okay, gasket pressure in the full gasket of area AG. AG stand for gasket. Okay, AG here is the area for gasket. Okay, usually gasket come with this, and also gasket is like in the previous slide. It is like this. Okay, you put gasket. It is the area of the gasket itself. Okay, AG stand for gasket. Okay, uh, gasket pressure found by dividing the force in the member by the gasket area per bolt stands for N bolts. And it's a number of bolts. Whether you want to find one bolt, two bolt, you would need to use two bolt, three bolt, or six bolt. That is the when you have to divide the number of gaskets with the number of bolts, and then the pressure come from normal pressure calculation. P equals to F over A. Okay, pressure, and then this is the force of the member, M, member, and A is the area of the gasket. Okay, so meaning that you when you are putting the gasket, you are putting the bolt. Okay, but under the bolt you should put a washer, and then the washer that is connected with the gasket. Another scenario is you put that part. Okay, and meaning that the bolt is not directly in contact with, usually the bolt is not directly in contact with uh, that mating component. Usually the member is in contact with the mating component. Okay, the nut, the washer, and everything lah. Okay, load factor for gasket. With the load factor N, equation 825, okay, we can written as Fm equal to 1 minus C and P minus in Fi. So, force in the member, okay, which is maybe the nut, maybe the washer, equals to 1 or minus C. C is the fraction of the external force. Also, C is the stiffness of the bolt itself. Okay, and P, N is the load factor. P is the external pressure. Okay, remember that if I given if I put force on the load, the force from my hand is the external pressure, and Fi is the initial force from preload. When you are tightened up, this is the force from the clamping force. Okay, substituting in the equation A in the previous slide. Okay, you can find the gasket pressure is P equal to initial force minus load factor uh, times P external force. Okay, 1 minus stiffness constant, and N is the number of bolt over area of bolt. This is area of bolt. Okay, and N is the number of bolt. If you want to use one bolt, two bolt, three bolt, four bolt, and much more. Okay, maintain adequate uniformity of bolts in the full gasket joints. Uniformity of pressure in gasket is important. To maintain adequate uniformity of pressure, adjacent bolts should not be placed more than 6 nominal diameters apart of the bolt circle. What does it mean by this statement? Okay, to maintain the rash clearance, bolts should be placed at least 3 diameters apart. A rough rule for bolt spacing around bolt circle is this: 3, where D is the number diameter of the bolt circle and N is the number of bolts. Okay, so 3 is the number of bolt, 6 is the maximum distance of bolt. Meaning that if you measure the bolt, if you measure, okay, then you get a diameter. Then you get certain diameter. Okay, so in order to maintain the pressure on the bolt, it should not be more than 6 times the diameter. Let's say you get this is 1 diameter, 2 diameter, 3 diameter, 4 diameter, 5 diameter, 6 diameter. Should not be more than 6 diameter of the bolt itself. If not, the pressure will not be distributed evenly. So that is what they mean by to maintain the pressure. Okay, should not be placed more than 6 nominal diameter from the bolt circle. Okay, because usually when you assembly the gasket, okay, usual practice lah, not necessary, but usual practice I say. Okay, you put the bolt here, the bolt here, the bolt here, the bolt here. Okay, and this is in the assembly. Put the bolt, and inside the assembly there is a gasket. There is a gasket inside. Gasket inside assembly. Okay, and then you want to position your bolt. Where do you want to position? Okay, you must design to make a hole not that too far apart. By standard must be should be not beyond 6 times diameter of that bolt. 6 times diameter. 2, 3, 4, 5, 6. Okay, that is the rough rule for that bolt. So that's all for the video. That's all for this video. See you in the next video. We'll talk about fatigue loading on tension joint. Thank you very much.